Hello. So I'm Mateusz, or you can call me Matt, like the short for Matthew. I'm from L2Beat. I'm half of the tooling team in the L2Beat. And my workshop is on the Discovery. It's the tool we built, to help us research projects. And it turned out that it is really useful at solving all of our problems. I mean, not all, but like majority of problems I'm going to later talk about. So a funny story is that I almost lost the demo part of this presentation, and the only surviving copy of it was like some random Vim buffer. So yeah, I just wanted to point it out. Okay, so there is a lot of projects on L2Beat. You know, the amount of project is growing, and we internally expect there to be at least 1,000 L2s. So currently, you can see that there is 51 rollups and 66 Validium and Optimiums. So around, let's call it 110 projects of only L2s. We also track bridges, not to the same standard, but for all of those L2s, we have a minimum bar of data we want to show, and that would be the risk rosette. We want the risk rosette to be obviously correct, and the standard for this data is actually quite high. We want to show data that is correct, so you don't lose your funds, you don't make a decision based on our data that is incorrect. So how to even maintain all of this, right? So just like a quick math lesson, right? So imagine that we have 110 projects, and every project has a single update every 2 months, right? So it's actually quite sparse. We see projects that are updating way more often. And even if every project had a single update every 2 months, we would have an 84% chance of seeing at least a single update in a day, right? So it's basically guaranteed that every single day something new will change on chain. We need to be able to detect it, see what's changed, and act upon it. And also, like, even if we assume that an update happens every 6 months, the chance is still 45%, right? So it's like a coin toss, basically. And these chances are basically always working against us. The more and more projects are going to be added, the higher those chances are basically to be 100%. So what is our needs, right? So like I said, there is a high chance of an update happening, and we need to be able to fastly see that it happened, and we need to be fast in reacting to it. If, for example, Arbitrum or Optimism, right, any of the top dogs has an update, and we take like 3 weeks to process that update, or to even like see that an update happened, then we are showing incorrect data for 3 weeks, which is actually a quite long amount of time when it comes to Web3. When an update happens, we need to know what changed. So it's not enough to see that something has changed. We also need to know what has changed, right? So did any of the risks assumption that we had before are now different? So also, we need to be able to look inside the project and compare to the previous version. And as always, we want to automate as much as possible. You cannot get to 110 projects listed on a website and do all of them manually. Like, it is possible with human effort, but we don't have the amount of resources to do it. So right now we have 4 researchers, and we maintain all of the 110 projects with only 4 people, and we also manage to do stuff that's additional. So Discovery essentially, like, I think, is at the core of solving all of those problems. Of course, Discovery is not a panacea. It does not solve all of the problems by itself. But of the problems that I listed, Discovery is always at the core of the solution. So the mental model of Discovery is like this. Like, I like to think about Discovery this way. And also I like understanding things from the low level. So let's try to understand the inputs and outputs of Discovery. The input, of course, is the Ethereum state. We want to see what is the state of each project on a given, let's say, block number. So the input to discovery is that Ethereum state. Of course, we are not sending like a snapshot.zip to discovery. We are doing something like, we use RPC providers, which is essentially having the entire Ethereum state at your fingertips. You can do any call you would like. And to facilitate the querying the data from the state, we have a config.json which instructs the discovery program which data we are interested in and how to process it. And after passing those two inputs to discovery, an output is generated, which is a discover.json file. Of course, it's all a simplification. The more the actual mental model, which I don't even think is correct, and is missing some parts, is more something like this. So that's what I mean when I say the discovery is at the core, right? All roads lead back to discovery. I'll try to, during this workshop, I'll try to touch upon all of the things that are listed here. So you'll be able to understand at least how this flowchart happened. Okay, so since I myself am a visual person, I want to show you a demo of something nice to look at. So this is something we have been working on, which will enable us to move from command line to a graphical user interface. So right now we are calling it Discovery UI, and let's see all of the projects that are listed here are projects that we are tracking with Discovery. So I have picked Zora for the project we are going to be using during this workshop. So let's see what kind of data we can expect to see in this tool for Zora. So of course there is a lot of things to take in, but let's start from the left and keep going right. There are on the left, the thing is that they look like files, but they are actually contracts. They are kind of inspired by the file view in Visual Studio, and you can see, maybe, I don't know, the contrast is not the best, but I hope you will see that we have two contracts which are the initial contracts. And by initial, I mean the contracts from which we are going to be starting, and all of the contracts that are on the left have been found based on those two initial contracts. So it is, as you can see, it is quite useful to be able to find two contracts used in a project, and then basically find all other contracts used by that project. And also this updates automatically, so if anything new happens, new is added or is removed, they are automatically updated. Each of those contracts has some values, right? So each contract has an address, a name, a description given by a researcher, and let's focus on the fields for now. So fields are state variables that we have found in the ABI, which are either public variables or functions which don't take any arguments and just return something. So we are trying to build the state of the contract through these. There is also one more part which will be important later during the demo, during the workshop part, which is that we try to build arrays from functions which take a single argument, which is of type integer. So we just assume that this function is get something by index, and we try to get all of those things. You can see that there are actually addresses inside of those values. And those addresses lead to other addresses. And this is how discovery works. It gets all of those state variables, and then if it finds an address, it assumes that this address is also connected and just keeps discovering on those addresses. And the third view here is like a graph view. So all of those projects here are used in Zora. And the way that it works is, for example, let's focus on the Security Council. Maybe not that, that's not the best, but the system config, right? So you can see that there are some state variables, and they point to other contracts. Through this view, it is really easy to understand how the project is built, what contracts reference each other, and how the data flow inside the project happens. Of course, this is not the default view. Like the view allows you to select them, move them around. You can color these, whatever your heart desires to make it easier for you to understand. We have two layout algorithms since it's a graph view. You can use like D3. We called it slow because it is not that fast. It uses force simulation to lay out the graph. We also have more like a hierarchical view, which just lays the graph from left to right. And the third thing is the code. So all contracts have source code. And let's go back to the L1 standard bridge example. And we want to show the code to the researchers, because to understand what a contract actually does, you need to look at the source code. And you might be weirded out by the fact that there are only two files. I'm going to touch upon this a little bit later, because it is actually quite important why there's only two files and not like more. So yeah, you can just view the code in here. The part that I want to also show is that we see that it is important to be able to switch between views, right? So I can click L2 output oracle on the left in the list view, and it is selected in the values and the nodes panel. Vice versa, I can select something in the values, and it is selected in the list and the nodes view. And I can select something in the nodes view, and it is selected on every single other view. So this is something which is like really graphical and nice to show. And it basically is only the look inside the discover JSON. This is just a nice way to visualize what's inside the discover JSON. But it doesn't touch upon the way of how we even got that discover JSON, right? So it is something we are working towards. It's not yet ready. You can only view things. It's basically read only at this time. But in the future, we hope to make discovery this. So you'll be able to do your research in a nice graphical environment and do anything you need. So yeah, let's get back to, yeah, go ahead.
So you were showing the source code, but the source code is not on chain, right? So how do you get this?
Yeah, so the question is, how do I get the source code since it's not on chain? So I kind of skipped one assumption, is that by the Ethereum state, we also kind of consider the Etherscan source code database. Even if you go to L2Beat and look into the projects that we list, if a project does not verify their source code on Etherscan, we give them like a big red warning. So we expect you to verify your source code to show transparency to the users and to the researchers so they can do their stuff. So it is something that are omitted, but we do use Etherscan or like Etherscan derivatives like BlockScout or stuff like that to get the source code, and we heavily rely on the source code, because if we didn't get the source code, we wouldn't be able to call anything because we don't know what the ADBI is, right? So yeah, if you have any questions, do please shut them up during the workshop. But I'll get back to the presentation.
Sorry, I have one more
Yeah.
question just following up from that. So if you run into something where you can't get access to the source, you don't try any kind of decompilation?
We don't try it, and?
You don't try decompile?
No, I mean, there was one case where we knew what the source was, it just wasn't verified. So we like forcefully, like we verified the source code for the project because they didn't want to do it for some reason, so we just did it. And we are not trying to decompile the bytecode in any way. I mean, if it's something that we can't get the project to verify and we need to look inside, we might decompile it, but Discovery does not try to do anything like that. It just assumes the happy case where the source is on Etherscan or whatever explorer the chain is using, and just goes from there. But yeah, if we hit a snag like there is no source, we just either accept it as we cannot look inside, or we talk with the team to verify the source code. Okay, if there are no more questions, I'm going to keep moving forward. So going back to the mental model, because I think it is really important, like if you leave this place with a single thing, it's just that Discovery is just a program. It has some input, it has some output, right? So the output is this Discovery JSON, and the input is the config JSON C. And the way you can think about Discovery, if it like makes thinking about it easier for you, is that it's like a scraper for a website. So scraping a website looks like you put some address of a website, it downloads the content of that website, it tries to find any links, and it follows those links recursively. Discovery essentially does the same thing, but it doesn't download websites. It downloads the state of contracts, and doesn't follow links, but follows addresses to other contracts. And of course, Discovery is not just like a simple thing that is like a black box. There are things happening inside that we are going to be talking about a little bit. So Discovery is able to detect whether a contract is a proxy. It does the source code flattening. I'm going to be talking about it later, like I said. It does template matching. It is something that also we are going to be touching upon during the demo part. It has custom handlers, which it executes. We are also going to be doing that during the demo. And it has typecasting. I left typecasting out because it is really, it would take like 20 minutes or 25 minutes to explain all of it. So I just left it out. If we have time or you were interested, you can hit me up after the workshop and I'll be glad to talk about it with you. And of course, there's like an engine that orchestrates everything. But yeah, it's like there are things inside that black box. So I have a demo prepared. There's a QR code. If you want to follow along with me, please do. And if you get stuck, I'll be able to help you gladly. I'll be going over the same thing personally. So if you just want to sit and just listen, no problem. The website has instructions, so you can do it now or later, whatever. And also, I really hope that the website works for you because like it's self-hosted. So if it doesn't work, try it, disabling your VPN, try a different country. I tried it like 5 times, it worked without any VPNs. So I'm going to give you like a minute to get to the website if you want to follow along. And yeah. Okay, I expect everybody to be on the website right now. If you didn't manage to scan the QR code or type it through, just ask your neighbor for a nice deed so they'll be able to show you the URL. Okay, so like I said, I'll be going over the same thing. Personally, I have it on my iPad, so I'll be going over all of the things that are written in here, and also I'll be like adding some additional context for it. And also, this is the important part. I forked Discovery from the L2Bit repository just for the purposes of this demonstration. If you actually want to use Discovery yourself, please use the original repository because I'm not going to be maintaining this fork, and this could get really stale really quick. And why did I fork it? It's just because we are not, it's an internal tool. We will try to make it more available to the public. It's just, it is on a rough stage right now, but it is still cool to show what this tool is able to do. Okay, so is this visible? Like the contrast is okay? Okay. So I have downloaded the only thing that I have done is just npm install. And if it worked, you should be able to just do npx discovery and something along the lines of this should appear. So there are two subcommands. You don't really need to worry about them. So there is the single discovery. It's just for convenience. If you really need to discover something like a single address, you put it there. But if you want to build like a project, you'll be writing a config.json either way. So there is also invert. Invert is like, we used it to build those graphs you saw. We used Mermaid before we got the protocol bit I was showing. So yeah, don't worry about those. The only thing that you're interested in is discover. So the most boring part of doing anything fun is setting it up and configuring it. Unfortunately, I'll have to leave the part of configuration to you. You need to configure two things. You need to configure the Etherscan API key, so you can actually call Etherscan. And you need to configure an RPC URL. And the sad part is that only few RPCs work that well with discovery. I'll say that the free tier of Alchemy worked for me without problems. So if you have Alchemy, do use it. There is like an asterisk where RPCs that only support block ranges of 10,000 when you're calling for logs do not work with discovery. For simplicity, we are essentially like expecting you to have an RPC where the block range for log squaring is basically infinite. So yeah, you'll have to set this all up. I'll just copy my env from the previous tries of that. So I have an env, and you should probably do the same. You can always like export the same variables if you want. So now we can get to the actual fun part. And before we actually configure anything, we need an initial address. The address in the website is already there, but like this is also a good question. Like, how do you actually get a hold of like any address that belongs to a project? And I'm going to show you like a simple example that you can find addresses belonging to a contract to a project. So we are going to be doing it this way. So like I said, I chose Zora for this presentation. So let's just go to the best website and find Zora. And how I do it is just go to their website of any project and try to bridge something. And also it is important, there are multiple bridges for Zora, for example, but what you want is the official bridge. I know it's a touchy subject, but in L2Beat, we assume that the official bridge is part of the rollup. I don't want to get into it, but make sure you have the official canonical bridge to use. And we just want to bridge like the smallest amount of ETH. And please don't bridge anything. We just want to get to the part where it says sign. And don't sign, please. We just want to get to the part where it shows us the address we are going to be interacting with. So let me just bridge some ETH. Yeah, whatever. Okay, so this is the address of the contract we are interested in. And we can just copy it and store it for later. So now, how do we configure the discovery to start at that address? So we need to create a folder structure that discovery is able to understand. So this folder structure looks like this. So just, I'll type it out here. So discovery is the folder where all of the projects that you will use live, basically. And they're like configurations, results, flat files, source code, anything that pertains to a particular project lives in discovery. And the actual project is like that. So anything that related to Zora lives in there. But there's also one more level, which is Ethereum. This is the actual chain you're going to be doing discovery on. Because we have the ability to do discovery on multiple chains, like I showed, maybe I'll go back. And the discovery why. So if you look here, most of these projects say Ethereum. But for example, zk-Link Nova says 10 chains. That's because a project can have contracts on multiple chains. And the way that discovery works is any EVM chain just works. It just, you don't really need to think about it. You just say that you want to use that chain. Of course, you need to configure the RPCs for it and the Explorer for it, but otherwise, it just works. So yeah, this is the path we want. So discovery /Zora/Ethereum. And in that path, we want to create a config.json C file. The C is for comments. It is also, there is many parts where you can see that it's not that ready for public release. I think discovery will fail if you don't provide, like if you just do .json, it will fail. So it is touchy. Okay, so what are we going to put into the config.json? So it is an object where you have to define two redundant keys, which is chain, and that's Ethereum, and also name of the project. So why do we have to type the name twice? Since it's already in like the folder structure. It's just for simplicity. If you want to read this config.json in a different tool, you'll still know for which project it is. And now we get to the simple part. There is also one more key which just says like what is the initial addresses. You can have multiple. We're just going to put the single one.
The name doesn't, it's like there's no validation on the name, but I think the name, right?
No. So the way we do it in L2Beat is that we have a bunch of tests that just validate if the config you have created is of what we expect. We also have like a bunch of assumptions where the name of the chain in the config is the same as the slug on the website, but we have tests for all of that. But you can put anything. Like you could put your name inside and it will just work. It's just like there is some schema that the discovery needs to see, and it's just like filling it out. But yeah, it's just a string, like as discovery is concerned. Okay, so we have put the L1 standard bridge as the initial address. And since this is a JSON C file, you can put comments. So L1 standard bridge. We are trying to, I know that half of the research team is trying to enforce this standard and the other half doesn't really try. But yeah. So now what we need to do is we need to run it. And this is another part which is like not the best, which is the way that the ordering is done in the folder structure is project chain, but on the CLI it's the other way around. So you need to do Ethereum Zora. And if you did everything correctly, it should start spitting out logs. The first run takes a little while, and if it fails, you'll probably know it failed. But the interesting part is here that we have gone to this address. Through the source code, we have found that it's named L1 standard bridge, and we have found four relative contracts or entities, like also EOAs, referenced by this contract. And as you can see, like, we are putting those relative addresses back onto the stack, and we are rediscovering them all. And ideally, at the end, we have 61 contracts or EOAs, and the discovery is done. We have like limits, so there is like a depth limit of I think 7, and there is also a max address limit. So for certain projects that we don't really know, or for like big bridges, the amount of contract is really big. The biggest project we have is Transporter, which has 350 contracts, and is really like, it is mostly just a stress test for discovery. So also pro tip, since like I showed you before, the mental model of discovery is this input-output, like a functional programming paradigm or whatever, is that you'll need to be rerunning discovery a lot. So like you saw, it takes some time, but if you look, there is a handy dandy cache. So discovery caches all of the calls you have made to a file. So if you need to rerun the same discovery, it already has all of the RPC and ESA scanner responses. So if you just pass --dev, I know the name is not the best, it will just reuse the block number of the previous discovery, and if you look at the speed difference, it's night and day. So please use --dev on any any reruns which are not the first run. So let's.
Is there a way to do this where you only are getting like 10,000 blocks at a time? Is that a flag?
Of logs?
Blocks.
Yeah, blocks, but by blocks, what do you mean?
Oh, my RPC.
Yeah, that's the problem that I was referring to. Are you using Alchemy? Yeah, so QuickNode is something that we don't. So we are using QuickNode for everything except discovery because it has this problem of only 10,000 blocks. We had code that managed the thing that you're referring to, which is like we did downloads by 1,000 block batches. It's really stupid. Like we had more time spent on trying to make it work than just like paying for a high Alchemy tier and just like doing whatever. So like I said, try to make a free Alchemy account. You can put Gavin Belson at Gmail or whatever. It'll be easier. I know that there are also like some public RPCs that support like infinite block range. For example, Envio. It's so envio.dev, but they only support logs. They're like really like a static indexer. But if you look into the README of Discovery, you'll be able to set it up. You can put like 2 RPCs. One is for everything except logs, and the second one is for only logs. Okay, so let's look. We have run the discovery, so let's look what it created. So we have 2 new entries. One is a discover JSON file, and the other is a .flat directory. I'm saying this, I think, for like a millionth time. I'm going to talk about flat files, but let's focus on the discover JSON for now. So in this file are basically all the things we have found during discovery, and we just like put every single thing into this file to try and make it as redundant as possible. If you look through the things, we have, of course, repeated Zora Ethereum, the block number at which we have run this discovery, the config hash, so if the config changes, we of course need to rerun the discover JSON, and the contract list. So the contract list is the thing that you're most interested in, but there is also an EOA list, so all of the EOAs that we have found, and an ABI list, so the list of all APIs attached to any implementation that we have found. And use templates. I'm going to talk about templates later. So each contract is an object. It has a name, it has an address, it has source hashes. Not really that useful to talk about it right now during the workshop. If you want to know, approach me later. Since timestamp, it's like when was this contract deployed. And values. Values is the thing that we are after, basically. It's the state of the contract at a given block number. So the state of it, like dollar sign something, is like a virtual field. We have created it ourselves based on some other values. But anything else is a state that we have been able to get just by calling the methods provided by this contract. As you can see, there are addresses like this, and some version stuff, whatever. There are things that are really useful in here, and stuff that is completely not useful in here. So you'll have to go through it and see if anything you would want to use is here. As you can see, like looking at all of this is not that pleasant. So we have also made, this was like before anything else. Before this thing, this is the OG way to view the discovery JSON. So if I just, oh my God, like I should find the guy who made the decision to make Finder like this. Okay, so we can pull this into the protocol beat tool. Protocol beat is the same thing as node view in here. So this view and protocol beat is the same. It's just it is easier. You can just drag and drop your discovery JSON into here. If you want to use protocol beat, I didn't think about it, but I don't have a QR code. You can just protocolbeat.l2beat.com. And it should just work for you. You can do all the things that I showed in the discovery UI. But yeah, let's get back to here. So there are a lot of errors, and what we want to do is get rid of them. And the thing that I was talking about, maybe you remember, is the errors are here because of the way that we build some of the state. Like I said, we do some assumptions during the initial discovery. So we made some assumptions that were faulty. One of the assumptions was that there is some finite amount of elements in an array. Turns out maybe it's not an array, maybe the amount of elements is bigger. So if we look, so let's try to find this is finalized in the discovery JSON. Okay, so we have is finalized, and we can see that there is an error. And here it is sanitized because we had problems committing our API keys to GitHub. But in the ABI, if we look for the same thing, we can see that we put an L2 output index, and it just says to us whether this index is a finalize. There is like too many indexes to contain, and also it is not that important. If we are really interested in, what we would much rather see is like the count of indexes that are on this project. L2 output, how many of these are there? But we are not really interested in any single one, so we can just like tell discovery, hey, listen, don't call this function, ignore it, because it's giving me errors right now. So I'm going to show you how to tell discovery just to ignore this method when doing discovery. So what we need to do is we need to find the contract on which this error happened. So as it happens, in the error output, we get the address right here. So we can copy that address and get to the config. So let's go to the config. And now we need to do some configuration per contract. So to do that, you need to create a new key, which is called overrides. And now we need to specify that you want to overwrite some things inside this contract. And now we need to say what you want to override. So for this contract, we want to say, hey, ignore methods, and we are going to supply the methods we want discovery to ignore. So just copy paste and rerun discovery. Okay, we are down to 6 errors. If you want, you can try to ignore more errors yourself. I'll give you like a minute to see if you got the hang of it. I'll leave you with the config so you have a cheat sheet. Yeah, so the biggest hurdle we have is mappings, like you say. If there is some mapping and there are basically no getters for it, it is really hard. So what we usually do is that if the source code is sensible, it'll basically always emit an event when it inserts something into that mapping or when it overrides it. We then build the value of that mapping based on the events. So we query for all of the events, and we rebuild the mapping state based on those events. But there is like no automatic way to do it. You have to look at the source code, you see which events are there, and rebuild it yourself. I'm going to talk about handlers later, but we have handlers for that, so we can do just that.
While we're waiting, you have a long list of L2s, and you've said that you expect, 1,000 or more. That's probably right. So how do you get started with this? Like, how do you find all the L2s? How do you find new L2s that pop up?
That's a question that is asked really often. I mean, in this Devcon, at least to me. And the answer, I think, is way less interesting than it appears. Like, I think that half of L2Bit is just chronically online, so we are on Twitter and we just know what is new. Also, projects just come to us and ask to add them. Also, projects just make a PR to our repository to add their L2. So right now, we have also we have a public Discord. So like there are many ways to basically message us about like, hey, can you review us? And right now we have around like 100 upcoming projects. So anytime this project will go into the mainnet, we'll move it from upcoming to the main page. But yeah, like I don't think there is any way. We don't have like a discovery for L2s. It's just like seeing what happens in the space, and that's it.
So how do you prioritize that?
How do we prioritize? So the thing is that certain projects, if a project is an offshoot of an OP stack, it is comically easy for us to find it. It's like less than an hour. If a project is more complex, so the prioritization always depends on how big the project is, how easy it is for us to add it, and also how many times they message us on Telegram per day. So yeah, there were certain projects. For example, I know that ZK-Link Nova has been in the waiting queue for a long time. They had a mainnet and they were waiting for a really long time because we just, we never saw this project before. So yeah, like we have to prioritize as anything else.
Can you consider just giving them the tools and say, you give us your configuration, you run this stuff, you figure it out?
So the funny thing, so the funny thing is that so I'll tell you that. So certain projects come to our GitHub, make a PR, and they have, their config JSON-C ready. They discovered all of this. They made the config file in TypeScript. And I don't think we had a single instance of an external team getting this right. So, I mean, they do try, but maybe it's a fault on our part because we don't have the best tutorials on it because like we didn't expect anybody to be using it, and we are expecting only us to be using it. Of course, this could change in the future, and we could say like, you need to provide a config.json file, but at the same time, if they provide a config.json file and it's small, like I said, it takes less than an hour for us to do. And if they provide a config.json file and it's huge, then we still need to look into it either way. So it's just, yeah. Okay, I hope that for people that are way too ambitious, they managed to do it. I'm just going to like flash things on your screen to go through it. Okay, if your config looks something like this, and you have no errors except the X domain messenger, then good job. So the X domain messenger error is also a fairy tale to be told, I guess. It's just, it doesn't provide anything useful and we ignore it. It reverts if you do a delegate call to it. You need to call the implementation. We always do calls through the proxy. But the output of it is not useful. It like returns, I think, some chain ID, which we already know. So we just ignore it also for any OP stack. Okay. So we don't have any errors. And we can now move on to handlers. So handlers are a way to get more state. Like there was this great question about like how do you find the state in the mappings? Because mappings don't have a good way to see what's inside. So we have handlers for a lot of things. So there are handlers like this is the event. Count how many times it has appeared, and put the number as the state variable. But these are really complex handlers, and I think like it will only confuse most of the people if I just start using handlers that are way too in-depth. To be honest, some of these are really complex just because we try to cram as much things into a single handler as possible. So to be honest, some of the handlers, I don't even know what they do. So a simple handler that I can show is if we go back to discover.json. And let's look, for example, let's say I'm interested in Gnosis saves, right? So I find me a Gnosis save and I see that there are members of this Gnosis save, which are the same as owners. And I'm just thinking, okay, so these are some raw addresses, but the thing is, what I'm interested in is like, is a given address an admin, right? So let's say there's some actor with a known address and you just want to know whether he is an owner or not. Of course, you could do like Control F and find it, but there's like a better way to do it. So if we look in the ABI of any Gnosis save, so you need to get the ABI, you need to copy the implementation. if you look into the implementation of any Gnosis safe, there is a function like this, is owner. You give it an address, and it returns you whether this address is an owner or not. So we'll try to see if Vitalik is an owner of some random multisig, right? So let's copy the name of the function, and let's go back to the config. And maybe, yeah, we also need the address of a Gnosis safe we want to do it on. So first, let's get the address. So this is the address we are going to be checking for is Vitalik an owner. Maybe this one. I don't want to break my presentation because I know there is one address which is different. But okay, so we are going to check is Vitalik an owner on this Gnosis safe. So it's the same as anything else. You just go to the config and you do some additional configuration for this contract. So now you need to say that what you actually want to configure is the fields part. So fields. And in the fields, you want to create a new field, right? So the name of that field is like, is Vitalik an owner? And the value of that field will be generated by a handler. So to say that, we are saying handler. The type of the handler is a call handler because we are going to be calling some function to get the value of it. And there are two additional arguments, which is like, what is the method we want to call? We want to call is owner, and also want to pass in that address as an argument, right? So we say args. And now we need to get the address of Vitalik, so let's just go to etherscan. Copy the address and add it. The args is an array because functions can take arbitrary amount of args. So for this example, it's only a single argument function. So if you do it like this and then rerun it, it should okay, maybe that did not work. Let me see. Okay, I guess I didn't save the file. So you saw this little hiccup that was there. Like most of those reruns are like really quick. It hiccuped because it was actually doing that call. It didn't reuse it from the cache because it didn't cache that call because we never did it before, right? So now is Vitalik an owner? False, right? So good job. So now I'm actually going to get to the flat files because it's going to move us nicely to the last part, which are the templates. So flat files, I have some slides for that. So we have built a custom flattener for the discovery. And I'm just going to try to convince you, or maybe I don't, to why we need this. So we are working on this L1 standard bridge contract, and as you can see, there are 33 files, which is the result of teams reusing code. OpenZeppelin being the standard library, they are trying to make the modules smaller and smaller. There is a lot of inheritance implementation of stuff. There's just also one thing I'll talk about, which is ballooning the amount of files in each contract. And if you try to visualize, like it's a single contract. Like, do you know what's happening? Like, imagine you're a researcher and you're like expected, like, yeah, good luck. And the funny thing is that if you look really closely, we are only interested in basically the blue contracts, and anything else we are not interested in. So if you look on the right-hand side, there is superchain config. It doesn't do anything with the implementation of the superchain config, but the thing is that teams more and more are basically reusing contract implementations as if they were interfaces. So when you do that, every single thing that this implementation uses is now also pulled in. And it doesn't have to be this way, right? So if superchain config changes their source code, it doesn't affect the bytecode generated by the Solidity compiler for the L1 standard bridge in any way, right? So if you cut all of this out, if you only leave contract libraries, stuff like that, that will affect the bytecode produced, you'll get something like this, right? Which is way more manageable. You have like 8 contracts, I think. If you take all of those contracts and like concatenate them together, you have like one big L1 standard bridge. So this is the reason why when we were looking at the code, we only saw a single file. That's because all of the files that we do write out from discovery are flattened by default. So it's really useful because we rely on those flat files a lot, because if you know that the source code in that file, when changed, will affect the bytecode, you can just focus on that source code. And the way we do it is we are using a parser for Solidity. It parses the Solidity, all of the files coming from Etherscan. Then we get an AST. We interpret the AST to find all of the contracts starting from the L1 standard bridge, which do actually affect the bytecode. So let's look at those flat files. They are here, and they are in folders if they are behind a proxy. So for example, address manager is not behind a proxy, it is immutable. But the L1 standard bridge that we are focusing on is behind a proxy. So the proxies get also flattened, and this is the entire thing you would want. So why I'm talking about this is that if you flatten the source code of every single contract, of every single project you have, you get some nifty bonuses basically for free, right? So since I see that we have a lot of time, I'll show you something that we have in L2Beat and that we use sometimes. So or maybe I'll not be able to show you that. Yeah, but the initial idea is that we have built a script that will take all of the flat sources and then compare the similarity between those flat sources to each other. So then you get like a big list which tells you, okay, so this project has this percentage of similarity to this different project based on the source code. Let me just try to see if it maybe will work. Okay. If the internet gods will bless us, we'll get it. Unfortunately. So if you really want to see this, I'll try to get it working and I can show you this after the workshop. We are able to basically cluster projects together based on their source code, and we get automatic clustering of, let's say, OP stack projects, and it works really well. You actually get like different clusters for projects which use fraud proofs and for projects which doesn't use fraud proofs. So it works surprisingly well. Okay, but let's get back to the workshop. So let's see the config. So let's say that you are not, you're not so certain about this single Gnosis safe, and you think that maybe they'll try to sneak Vitalik as the owner into some different not safe. So what do you do if you want to manage this handler in two different nonce safes? So the first instinct is just to copy this entry and just repeat it, just change the address. So let's just do it. Okay, so we are going to be checking for Vitalik in this nonce safe. So now in discover JSON, is Vitalik an owner? Is in two places, right? So it's here and here, right, on line 45 and 174. But if you look, like, it's not really the amount of things that we have changed, it's only the address. So just as with code, like, there's some duplication, right? And if some duplication happens in your source code, what you do is you create some abstraction that says that all of this functionality or behavior can be encapsulated to a single function, a single class, whatever, right? So how can we do the same? How can we pull out this configuration, call it something, and reuse this across contracts, across components? So this is where the templates come in. So in discovery, I will have to show you this way. So in discovery, we have discovery here, and if we do, if we list, we only have Zora, but we have to create a directory underscore, it's templates, yeah, underscore templates in discovery, and it will, just as discovery houses all of the projects that we have, templates will house all of the templates that we have inside, right? So let's create that, and let's create our template. With something that's weird is that templates are not files by themselves, they are folders. Why this is the way that it is, it will appear, it will explain itself in a second. So I'm just creating in the templates, I'm creating a single template called my template. I mean the directory for it. So we are creating this directory for the my template, and let's create a new file inside, which is template.jsonc. And we can just, as with code refactorings, we can just take out in the config the thing that we need to pull this out into a separate file, and that's it, basically. All we need to do right now is say extends, and we say the name of the template. And we can do it here also. If we rerun and check the discover JSON, it is still in two places, right? So what this gives you is a lot of leverage. So let's say that I want to see if maybe somebody else is also an owner in nonce safe. So let's see if a different address is an owner. So since I don't know any addresses, I'm just going to use dono.eth. And it's the same thing as before. We are creating a new field. We are going to call it is Dono an owner. And pass in the argument. And let's rerun every single thing. Okay, and now in two places, there is Vitalik and is Dono, right? So is Dono, is Dono. As you saw, we only had to change a single file. And in the case where there is only a single project, it's maybe not that useful, but like imagine that we have thousands of L2s and we want to check something across those thousands of L2s. Changing only a single file instead of all of the configs for different projects is way more useful. And the way that we use this template is we said manually that, okay, use this template. And this can also get pretty boring. And let's say how many Gnosis saves are here. There are 9 Gnosis saves inside of this discover JSON. So I could either repeat myself 9 times in the config, or I could allow discovery to somehow automatically associate this template with any contracts that look a certain way. So this look a certain way is where flat files, again, come back into the picture. So what we can do is, like I said, like if we flatten a file and we know that this, the code inside that file, when changed, will change the bytecode. And if we say, okay, so the source code of this thing is something. So for example, here, we'll be saying the source code of this is a Gnosis save. So we can, in the my template, this is why it's a folder, we can say, okay, we have some shape files, which essentially means if anything looks like this shape, match that template automatically. So to do that, let's just go to the flat files and pick the implementation. The only thing I have to do is copy the implementation and paste it here. And now, when I rerun the discovery, you can see in the logs that there are logs about certain Gnosis saves being associated with a template, and the reason being by shape match. So essentially, what has happened is we have downloaded the source code for this contract. We have flattened that source code, and what we did is we found that the shape in this contract, in this template, looks like the source code for this contract. So we have automatically assigned this to this contract. And this can get pretty powerful. This is why I'm saying that for certain OP stacks, like it's less than an hour. So the only thing that we have to do is just like input a single address, and the discover JSON, like the output, looks the way that we want, right? So if the team did not do anything fancy, did not do anything too custom, it just works, right? So if we now look into the discover JSON, there are 7 instances of is Vitalik an owner. The reason being, like I said, some teams change the implementation of certain things just a little bit, and if it's not even if it's like a little close, we still don't do it. It has to be 100% the same. We also have run into problems where the source code is the same, but for example, one team uses a certain style of indenting or one style of formatting their comments. So we also have a formatter, like a really, maybe not human-friendly, but really computer-friendly formatter that takes the source and formats it into the same, like minified, yeah. And then it can compare across files. And since this works so well, we can also remove these two. Don't forget the comma at the end, and rerun. We also have 7 entries. So I see that I'm doing it way too fast. I have still 40 minutes. So like it's basically, this is the end of what I wanted to show. I can try to show you some of the things that we have in L2Beat that make researching the things simpler. So maybe let's start with going back to this diagram. So we have talked about, if you look on the left side, on the inputs, templates are also inputs to the discovery. We also have talked about flat sources. And flat sources, like I said, are used to compare project similarity. We talked about protocol beat. The only thing that we didn't talk about is update monitor. So I said that our needs are that to have the ability to react quickly to changes inside the project. And update monitor does that, like solves this problem. So what update monitor is, maybe I can show it. I hope I don't have anything embarrassing. I don't know, do I have an embarrassing internet or is Discord embarrassing? Yay, okay. This is our update monitor. So what update monitor is a bot or like a program that takes each project, reruns the discovery on it every single hour, and then does a diff on the discover JSON to see if anything has changed. And this way we can get like the maximum amount of time for which the update can be stale or the data can be stale for on our website is 1 hour. And you know, even here in the Discord channel, you have quite a good understanding of what has changed. For example, yeah, so this is an amazing example. So Molten has done a upgrade of their RBOS to a new version, and like we have descriptions and severities to help us understand what has actually changed, right? Because somebody has put the time and effort to understand what is a WASM module root, what is an RBOS from, this is basically the same, but it's like translated. So somebody has put in the time and effort to understand all of this, and we add like additional descriptions to the config JSON, so you can know after the fact what has changed to be able to understand the change even quicker. And we do something like this where every single day we have a like a summary of all the changes we need to look at. So as you can see, for example, this is actually a lot of changes we need to look at. The way that it connects to our website is that if any project has an implementation change, so you can see, for example, that Tycho is right here in the waiting queue. And the way that it works, if a project has an implementation change, it's automatically moved to in review on our website. So if you go to L2Beat and check out Tycho, it is in review right here. And nobody has moved it to be in review. It was automatically moved to in review. And we want to show to our users that, look, this implementation has changed. Some of the things that we are saying might not be correct. And we even, I think, show to the user which implementations have been changed in the smart contract section. Yeah, so now you know that the implementation of these two contracts is different. So now be careful. Either you can wait for us to take a look at it, or you can just accept the risk that comes with it. And yeah. So that's update monitor, and I think I'll end it at that unless you have any questions. So we were really ambitious to categorize every single field inside the discovered JSON and assign it a severity, right? So for example, let's imagine there is Vitalik an owner, right? Or like we have that somebody cannot become an owner because the world will explode or something like that, right? Then we would assign this field a high severity. So anytime this would change, we would sort this project to be higher because something with high severity has changed. As you can see, there is also this fourth column, which is nobody has assigned any severity to it. And most of the projects don't have any severities. I mean, most of the fields don't have any severities assigned to them because it's just a lot of work to do so. But yeah, does that answer your question?
Yeah, so the fields are predefined. Severity of the changes were predefined.
Yeah.
Thank you for the answer.
Two quick questions. One is, it looks like you associated templates with a given L2. So, is that right? Or did I miss it?
We associate templates with a given contract. I mean, with a given implementation of a contract.
Okay. And so, if those templates are buried in given projects config, is there a way to take templates and make them global? Is there any kind of template hierarchy?
Maybe I can show how templates look in L2Beat. Because all the things that I showed are not maybe amazing. Leave me alone. Okay. So this is the, can you see it right here? It's good? Okay. So we have the templates that are in L2Beat. And what you can do, you can create directories inside the templates and then try to categorize each template for like a given stack. So for example, we do associate templates not maybe with L2s, but like the stacks that they use. So we do have an OP stack template, like there are a lot of templates. So for example, the L1 standard bridge has its own template right here. It looks like.
Yeah, okay. That's what I expected. An answer to my question.
Okay, yeah.
And then the other question I had was, I assume that the web UI that we're looking at is entirely generated from this information. Is there any information that shows up in that UI that's out of band, that's done manually or so?
No. I mean, all of this is like every single thing. So, for example, let's go back to the UI. So this is Zora, right? So every single thing that we are showing for Zora is on my laptop and would be the same result if we were to run it on the data that we have found in the workshop session, right? So we are not making any additional calls to anywhere else. It's all local, basically.
Thanks very much.
I didn't quite catch how to load in the discovered JSON into this discovery tool. The website or
Oh, yeah, so there are two tools. I know it's maybe confusing. So this is Discovery UI, and it has Protocol Beat in it. But to load something into the Discovery, it shouldn't say Discovery UI at the top, but to load something, you just take the Discover JSON and drag it onto the website. Okay, any more questions? So I specifically chose Z for this presentation because any single time I try to share my terminal, and because I use Vim, so it would be just way too distracting to like try and show, you know, workshop stuff on the terminal. But this is Z with Vim bindings. Okay, thank you. Hi.
Okay, okay, I think now it's on. So hi everyone, welcome to the workshop. It's going to be, we're going to be building a lot of cool stuff, but just for a quick intro, my name is Eda, and I'm part of Build Guild, which works on tooling and education in the Ethereum ecosystem. And what I'm going to be showing today is building an gases NFT minting application where we go over Coinbase's smart wallet, create like our app from start. So hopefully we'll be going from like no app to like an app in the next 1 hour and a half or so. And I just want to see, even before we start, anyone has worked with Scaffold ETH before? Okay, 1, 2. Oh, awesome. Okay, nice. Yeah, we have quite a few workshops during this Devcon, but that's cool. Well, hopefully this will be a nice intro. It's not necessary to have worked with it before. We'll be setting it up from scratch. Okay, so let's directly jump to it. So this is the workshop which I'll be following. You're welcome to like go to this URL. I'll be doing everything from scratch, so no need to like go there. But if you would like to like follow along, EDA Octurk 14/Devcon 24. I have the instructions there. In case I get stuck, I will be defaulting over here. Okay, so hi everyone. It's nice to see like a larger crowd, especially on a rainy day. I don't know if it's still raining, but it was raining when I was coming here. Cool. So I actually did download it just to make sure that we have it set before we start the workshop. But I want to show everything from scratch once again. In case anyone wants to follow along, you're welcome to follow along with your laptops. If it fails, we'll default to the one which I already downloaded, but hopefully the internet is quite fast, so we won't be having that issue. Okay, so for Scaffold ETH, a quick intro. You can go over to scaffoldeth.io, and this is like your starter page, kind of explaining what the tool is all about. So the key here is that it gives you a fast way to interact with your smart contracts and to create a front end, especially if you want to like work at hackathons and build tools in a short time. This gives you a starter template for anyone new getting started. What it is like it has like a Next.js component, which is the front end, and then it has your smart contract piece. And you can either choose Hard Hat or Foundry. So when we set up the wizard, you can choose like your development environment of choice. And let's head over to the docs to give like a quick intro. Yeah, Hard Hat or Foundry, it uses WAGMI, VM, Next.js, RainbowKit, and some Daisy UI for out-of-the-box front-end development. If you're not like a front-end developer, you can still like hit the ground running with using Scaffold ETH. I'm not, so it just provides me a lot of benefits directly out of the box. And even before getting started, I can actually like go to speedrunethereum.com. So once you kind of get the gist of Scaffold ETH and like building with it, what we always recommend is to go to speedrunethereum.com. It's again built by the builders at Build Guild. And basically, it walks you through different applications to build on Ethereum, starting with an NFT application, a staking contract, token vendor. So for any developer who is getting started with Ethereum, these challenges are a great way to work on your smart contract, work on your front-end tool, and just to kind of get building quite fast. And is there anyone like who's hacking at the hackathon this weekend? Okay, I think this might be useful. Perfect, cool. Let's get started. So what I'm going to do is I'm going to use the npx create ETH, and then I'm going to follow the wizard to help my app get started. And as I said, I just downloaded it before, but I'll be doing everything from scratch in case like we have any issues with the internet, which I don't think so. I got the command from scaffoldeth.io, just copy the create ETH latest command. I'm going to set up my app from scratch, and then I'm going to show what the app offers. My project name, let's call this Bangkok Devcon. I'm going to use Foundry, but if your development environment is Hard Hat, you're welcome to choose that. I generally default to Foundry. And it's going to get everything set up for me, and I'll be walking through it. But the main components are, it gives you like an out-of-the-box burner wallet, so you don't need to like connect your MetaMask or any other wallet. It just makes your life very easier, especially when you're like developing and you don't want to like connect your MetaMask on every transaction. It also has like a built-in faucet, so you can directly get it. Like it starts your local development environment. So because we chose Foundry, it will directly like get us like an Anvil chain. And then every time like you make changes to your smart contract, you can redeploy them. Like you will just run a command to redeploy your smart contracts, and then it will automatically inject the changes to your Next.js app. So like you will have like a debug contracts tab on your front end to kind of work with it out of the box. Just a few more seconds to install everything. And to make sure, like I said, everything about Scaffold ETH, for any developer interested in Ethereum, I think it's a great place to get started. You can learn more about BuildGuild at biddlegiddle.com as well. I say BuildGuild, but it's actually BiddleGiddle. And you can see like Speedrun Ethereum, Scaffold ETH, all the stuff that you can kind of use for education. This is almost done, so we're going to get to like the VS Code soon. And once we have it, what we're going to be doing is we'll be adding like new smart contracts. We will be building an NFT application, so I'll be using like an ERC721 contract. I'll be working with that, and then we're going to be showcasing the smart wallet capabilities by having it like gasless minting, so you don't need to pay for gas. This way, like hopefully, if everything works out in time and we have enough time for it to work out, I'll send the link, and then everyone can like mint their NFTs. Cool. Okay. So we have this set up. Let's go into our, let's see what this is. And I want to move this here. Let me first run it, actually. So to run it, I'm going to move a bit fast, but all the information is available in the docs. I'll still try and go like slower, but if anything is missed, everything is already available in the docs and the link that I shared. So I'm going to do a yarn chain to start my local chain. And as you can see, it starts my annual local chain over here. It's all on localhost, so no connecting to. We'll be deploying to base Sequoia in the end, but right now we're just working on localhost. I'm going to do a yarn deploy because there's a default smart contract which I want to deploy directly. And then I just opened like a new tab and doing like a yarn deploy, blah, blah, blah. Okay, this deployed. I'm going to open like a new tab and do a yarn start to start my Next.js application on a new tab. And you always need to have like yarn chain running because that's where the contract is deployed and that's where like your front end is looking to. Okay, this will hopefully open up. It always takes a moment longer in live workshops than working at home. But perfect. So this is what we kind of got set up. To showcase the features, we have like here the debug contracts tab, which introduces a basic smart contract. You can kind of test with it. You can set a new greeting. This is a burn-in wallet, so I'm not connected to my MetaMask. It comes directly out of the box. It's stored on your local storage, so you don't need to worry about connecting to your MetaMask. There's a built-in faucet, so I can just click it, and I'll get like 1 ETH on my, well, I clicked it twice, so I got 2. But I can get some ETH because when I want to make a change, like let's set a new greeting. Hello, Devcon. Send. As you can see, I changed the greeting. This is basically a variable in my smart contract. And yeah, my balance is lowered because I had to pay gas for the transaction to go through. And this is what comes out of the box with Scaffold ETH. The main features, especially like now you have like the smart contract tab where you can edit your smart contract. You have the burner wallets, and then you have the faucets, which I think are the most useful. And as you can see, like I spin up like a full Web3 application in just 5 minutes. I think it would have been a lot faster if I didn't talk this much. But this gives a lot of flexibility to move fast when you want to build an on-chain app. Okay, so what we're going to be doing today is we want to add like a new contract. We will be working with an ERC721. And for that, I'm going to go to OpenZeppelin Contract Wizard. This is a really great site by OpenZeppelin where you can kind of craft your smart contracts. You're welcome to follow along as well. You can use this, or if you want to use like Soulmate with Foundry, you can go to the Foundry docs and like get a smart contract of your choice as well. I'll just be using the OpenZeppelin smart contracts because I think they're sufficient. And one other thing is I want my NFT to have an image. For this workshop, I think I'll be using like the image we already have, so I'm not going to be like getting a new picture and adding it on IPFS, but instead I'll be using this Bufficorn image, which we already have somewhere here. Sorry. Okay, let me just add it a bit later. But for now, I'm going to be calling this NFT. This is just changing my smart contract. I'll be copying what the wizard says to my application. Let's call this Edda, because my name is Edda. I'll be adding a base URI in just a bit. I want to make this mintable, so it automatically mints, it automatically adds that future. Let's also have auto increment the ID, so then every NFT we add has a new ID, which is automatically incremented. And then I'm also going to make it enumerable, which directly allows me to track who has an NFT. You can also use other tools like the Graph or Ponder for off-chain, doing this, getting who has which NFT off-chain. But for the sake of this workshop, I'll be using the enumerable. My English is limiting, but that smart contract. So then we automatically have the people. We can keep track of the people who have the smart contracts. I think this is all we need. I'll be adding the base URI once I get the image as well. I just want to kind of quickly show this. I'm going to copy this to clipboard, and then let's go to our application, which I actually did not show just yet. So this is the Scaffold ETH application, which we just downloaded. I called it Bangkok Workshop when we were running the wizard, as you guys saw. Am I talking too fast? I can definitely slow down. I feel like sometimes I tend to talk too fast. Okay, it's good. So we have two packages over here. We have the Foundry and we have the Next.js. The Foundry is where we'll be working with our smart contract. The Next.js is our front-end piece. So I'm going to first of all work with the smart contract piece. I'll be adding a new smart contract, and then we'll add that to our front-end in a bit. So I go to the Foundry folder. I go under Contracts. There's this yourcontract.sol. I'll zoom in a bit. This is the smart contract which we were just interacting with. I want to add a new smart contract here. And I'm going to add a new file. I'm going to call this nft.sol. I'm going to copy paste what I got from the wizard. I don't want to make it ownable so that anyone can mint. I will just omit extra stuff for the sake of making it simple. You can have it ownable. And you probably want some owner when you deploy the smart contract to be the owner of that smart contract you deployed. But for this workshop, I think it's okay to not have an initial owner. I'm going to remove this from the constructor. Oops. And then I don't want this ownable. And I need to remove the only owner modifier, blah, blah, blah. Okay, cool. So all I did was I went to OpenZeppelin Wizard, got an ERC721 contract, and pulled it here. Now, I also need to update my deployment script. The way Scaffold ETH works is you have the deployment scripts, which deploy the smart contract. And they're under, I think, scripts. OK, perfect. So the deploy your smart contract, this is what deploys a smart contract, which we just had. What I need to do is I need to create a new deployment script for a new contract, which I added. And I'm going to take the easy route, and I'm going to copy-paste this. And I'm going to call this deploy NFT contract. I need to remove the copy. So we do this. We change this to NFT. Deploy helper, deploy NFT contract, scaffold deploy. Let's call this NFT. One mistake, which I generally tend to do, is mismatch with the renamings. So the contract we named was called NFT over here, as you can see. So sometimes it's called your NFT, so be careful with when you do the renamings. I feel that's a common mistake, which I tend to do. And we remove the constructors, or actually I think this is fine. We don't need the deployer, do we? OK, I think this is good. Now, this is not enough, because when Scaffold ETH runs, it actually runs this code. So we need to add a new line over here saying that also run this script when you run the deployment script. Because what we did was we created a new deployment script, but we didn't indicate that that should also be run. And thank you to the developers who actually added it easier, deploy more contracts here. So all I'm going to do is I'm actually going to deploy my, I think it's called NFT contract, right? That's what we named it. Deploy NFT contract. We probably need to import this as well. I'll just import this. I think, oh, it didn't give me. My GitHub Copilot it usually gives me the error. Perfect. Okay. Hopefully this will work. Let's see. As you can see, all I did was I added a new ERC721 contract. This is like the NFT contract, which you can make, you can use directly out of the box. And I added the deployment script so that it actually gets run and we can add it. And hopefully this will work. Let's see. If it doesn't work, it will give us an error. So we'll see what the error is. I keep my I keep my Yarn app open. This is the Yarn start. I have over here the Yarn deploy tab. As I said before, like the Yarn chain is always open too, so I'll just leave this here. So our Yarn chain is running, and then our Yarn start is also running, but here we will deploy the contract once again. I'm going to do reset just to reset like anything that was saved and deployed. Cool, so execution was successful. So let's see what this means. Okay, so as you saw, I didn't change anything in the front end, but now I have this NFT tab. So this directly comes because it's like, this is kind of the main reason of using Scaffold ETH. Now I can directly test the smart contract on my interface over here. So, you know, it has the NFT, the symbol, the total supply, and this is a basic NFT contract, which we just added, and now it's available for us on the front end. I do want to add the image. So I'm just going to go over here. I'm going to, oh, not here. I'm going to close this. I'll go back to this. Okay, so this is the image which I'm going to use for my NFT. And I'm going to go back to my wizard, and where did we add it? We had our visit over here. I'm going to add it here. It's basically just going to add the base, like the base URI. So I'm going to copy this once again. What I did over here is I want like my NFT to also hold like an image. You can definitely have it on IPFS or like a decentralized server. For my case, I'm going to just use the address like where it's available. And then I'm going to go back here. I'm going to change this back. I'm going to remove the ownable stuff, which we just did. Not ownable. I'll remove the constructor, so our constructor argument doesn't take anything. The modifier here. Now, one other thing which I want to do is I want to limit the number of times this NFT is minted. So I want like a max supply. There is no max supply by default, so I'm going to be adding this uint 256 public. Oh, wow, it already added it. I don't think we need to make it constant. I want to make it like this. I'll make it like 30. 30 is good. I'm also going to change this to public. Even if it's private, you can actually access it, but I want to access it from my front end, so I'll directly change it to public, so then I can get the next token ID in my front end as well. I added the max supply here, so I also need to update my minting function so that it doesn't update if it's past the max supply. So we need some kind of way to make sure that we are not, like, if it's the 31st token, it does not like mint it. So I'm going to use like, oh, GitHub Copilot is helping me. I'm going to use a require statement. So if the next token ID, now this is automatically incremented whenever a new token is minted. As you can see over here, the token ID ++1. So whenever we mint a new NFT, the token ID is incremented. And if the token ID is like less than the max supply, we continue. But we added a require statement to make sure that the max supply is not passed. Cool. So whenever you make changes to your contracts, you need to redeploy. Nice. Okay. So we redeployed our smart contract. Now we have a max supply of 30. Like, let's test this person. Like, this is the pink green person. This is a burner wallet, so it's not my MetaMask. And let's see if like this person can deploy. Where do we add it? Mint. I want to mint to this address. I'll send. This person already has like some funds in their burner wallet, so they won't be getting a gas error, hopefully. Okay, so we minted an NFT, and as you can see, the token ID increased. Now the token supply is, now we have one token which is minted, and I can continue to mint. and then it will be 2. And then I can open like an incognito window. Let's go over here. A new wallet address is generated because it's a burner wallet and it's in my browser's local storage. I go over here to the debug contracts tab. I copy this address. There's 2 contracts. We also have the your contract, which we didn't change. The NFT one, down, copy. But it will give me an ask gas error because this person does not have any money to pay for gas. Yeah, gas required, no available. And again, the faucet is very helpful here. I just click, I get money from the faucet. So now I have 1 ETH, but it's on Foundry, so my local host. Safe mint, Okay, as you can see, the next token ID is increased. So whenever you open a new browser, you don't really need like a wallet already there, but you can test with different users, which makes it quite easier. Okay, nice. So I think we have quite a few things already. What I do, I'm gonna have a look at my notes to make sure I'm not missing anything. But I think we can slowly move on to the smart contract piece. The buffalo, we have, this is our NFTs image, the buffalo icon. This is my, no, not this one. Too many tabs. So we set up our Scaffold ETH application. We tested it out. We added a new NFT smart contract. We added a max supply over there. We did add it to the contract. So this is probably some like you. This is just an example. It's not the smart contract we used. So if you do follow this like README guide, beware that the code is more like for example, so that I don't give the whole answer. But I will be pushing everything to GitHub. So like I'll be providing the code in the end. We added a new NFT contract. We updated our deployment script. Now we can start building our front end. Awesome. So let's do that. Now to update our front end, we were previously in the Foundry folder. I'm going to be going to the Next.js folder to be working on my front end. Okay, so I have the app over here. What I need to do is I need to create a new folder called NFT, and then whenever I go to localhost-NFT, it will automatically go to this page. I'll also add it to my header, so then it's easier accessed. And shout out to these people who are the builders of Scaffold ETH, actually. So thank you for making the lives easier. New folder, NFT. I want a basic page.tsx. I'm just going to copy this and paste this here. In case I went fast, just to kind of reiterate what I did, is I went to the Next.js -app created a new folder called NFT, and I added the page.tsx over there. But we can actually just remove all this, and we can just say, hello, biddle. And then I don't want to have the stuff we don't use imported, because it looks bad. I do want to change this to NFT. Okay, hopefully this will work. We actually also don't need this. Let's just, or let's leave this there. So now, when I go to localhost, I can do a -NFT. Hello, biddle. So we will be working on this app over here. We'll, of course, be editing it, so it will not be this view. And one other thing I want to go even before editing is I want to add it to my header to just make it easier accessed. So then you don't, when you're testing, you can just click the header like home. And I think that's in the header somewhere here. Let me just modify the header. Let me see. I can actually search for debug. I'm going to add it here. So it's my header.tsx. I go over here. I add a new NFT tab, and let's go to NFT. Hopefully this will work. And now we have a new tab on our header called NFT, which we can directly go to instead of just going to localhost-NFT. And let's see. Okay, perfect. As you can see, we added this, the NFT tab. And now we'll actually be building this because this is not what we want the app to should be. Okay, So what I want to do is I want like a basic card which shows a button which says mint, and I want to provide the details of my NFT. So like imagine a website where you go to mint an NFT application. That's what we're going to be building. And then hopefully we'll also show what NFTs the user owns, and then we'll make it so that one user can only have one NFT. And that's kind of the goal. We'll be working with the front end a bit now. And for that, let me take this like this back to have the, so then I kind of use the default stuff available, or I will be removing this part, but I just wanted the divs already to make it a bit easier for me. And let's say hello here. And now what I want to do is I want to add a card. Oops, it has my automatic settings. What I'm going to do is I'm going to go to Daisy UI. So as I mentioned, Scaffold ETH uses Daisy UI, which are pre-built Tailwind CSS components. So you can click to Daisy UI to kind of see what components you have out of the box. And actually this is, I directly want to go to components. Can I click on components here? So this way you can directly pull in these components into your front end. So I want to pull a card component. Like there are different components such as the bubble, the checkbox, the countdown, divider, stuff like that. I'll just be using a basic card. I think I've used this card so much that I remember the joke, and I never thought it was funny anyway. So I'll copy this. I added the card. I didn't change anything. I just went to the Daisy UI website. I chose the component I want. I copied the card component, and I added it here. So for now, like no modification. And then we can close this now, NFT tab. Okay, we have the Daisy UI card, which is the shoe card, which we are going to erase. I'm going to delete the figure. I'm going to delete the joke. And then what we have, okay, shoes, buy now. I actually don't want this. I want this to be in the center for now. This will be like a mint button. No functionality, just wanted to like showcase the front end a bit. And then what is this? I always feel less creative when I have, like when you're on a live workshop or something. So I'm going to call this NFT app. And let's call it Speedrun Ethereum. Okay, cool. So we kind of have our basic app, but you kind of want to show the max supply, or like how many tokens are left, right? So if you imagine like an NFT app, like an application where you can mint an NFT, you come over here, you're like, oh, I want to mint, but like, what am I minting? You kind of don't want that. So I'll be like adding the details of the smart contract. And then obviously this mint button is just a placeholder for now. It doesn't really work. But let's make this a bit wider. Let's make this 96. Is this too wide? Okay, maybe like... Okay, cool. So what I want to do is I want to pull the details of my smart contract onto my front end. Now for that, I'll be using the Scaffold ETH hooks. This just makes it a lot easier to kind of work with. It's using WAGMI in the backend to create the hooks. And you can go over here to interacting with your smart contract. First, we'll show off the read hook, and then we'll also work with the write hook so that you can actually mint your NFT. Now the read hook is over here. You can see like we have the default example. It goes to the contract, your contract, and it gets the function use greeting counter. We'll be changing it, so we kind of want the max supply and the token ID details for ours. And then our function won't be taking any arguments. But you can come over here, you can get the read contract hook. Let's do that. Coming over here, just add it here. I'm basically doing copy paste most of the time whenever I program. Import. We directly import it. This is not going to be total counter, but this is going to be from contract name. I think we named it NFT. And we called it max supply. max supply. And it doesn't take in any arguments, so deleting this. I don't want to call this total counter, but I'll call it max supply. And then what should we do? Let's add it like a header over here. So supply left, max supply. This is actually not supply left. This is total supply, but we'll add the total like supply left afterwards. And then let's also show the connected address for now. I'll delete that because it's already in the app, but I want to show off the components available in Scaffold, like the account component, which makes it very easy to have like a tailored account component, which matches like your, if you have an ENS account link, it automatically like makes ENS resolution. It shows like your avatar if you have one. So I do want to show that as well. And let's add like a new header here for our account. And first of all, before showing that, let's see how it looks without like the Scaffold component. So all I did was connected account. This is use account from directly WAGMI. So very easy to like get the account details. I just call use account, and then I display it over here. And this will not be nice because it will show like a 0x string, which will be like outside the card border. Yes. And the total supply is actually not shown because I think we need to make it like number, because it will result like a big int, which will not be displayed. Okay, yes. So, but this, the way this looks is not pretty, right? Like you wouldn't want to mint an NFT from this page. So I kind of want to make the account a bit more prettier. And what I'll do is, instead of like having it like this, I want to use the account component. We'll be removing it afterwards, but I think it's nice to showcase. Over here, I come to, I think we can search for account component here. Recipes. Oh, I keep saying account, but it's actually address. So I'll be getting the address component here. Account address. Now what this does is, as you can see, you can directly use like the address component and then add it. And here I go. Address, I need to import this. Okay, I think this is taking a moment. Copilot is slow today. I should get it from Scaffold ETH. Directly getting the address components. Let's leave the connected address just to show the difference. Okay, perfect. So as you can see, there are two different ways you can display the address. And I'm directly using the address component, so this looks like way prettier. This address doesn't have like an ENS, so it doesn't like resolve. But if it did, you would kind of see that over there. And I'll delete the ugly one. Okay, cool. So we're kind of getting somewhere. We still have like over an hour, so we'll get to like the NFT minting part. I'm gonna cheat and look at my notes for the next step. But basically what we have is we can kind of work towards, we want to do a few more things. Like when we think about like our NFT application, we want to allow gaseous minting. That is one thing which we want to do. The other thing we want to do is we want to keep track of like when you log in and let's say you have an NFT, you want to see that, right? Like you want to see like your NFTs part. So that is the second thing we want to do. And maybe I'm forgetting something, but the rest will be in our notes. We still have our debug contracts over here. And then we will, of course, like ship this app. So we'll do like a Yarn Vercel, like YOLO, and like host it on Vercel. So then I'll give like a QR code so everyone here can mint the NFT. It'll be on base Sefolia, so no money needed. And actually a big gas sponsored, so you don't even need to have any money to like any base Sefolia ETH to mint it. Okay, I will go back to my instructions. We did this. Oh, we didn't add the minting function. Okay, let's do that first. I'm going to go over here. I think it's here. So we added the read hook, which allows us to read from the smart contract, but we should also add like the write hook, which allows us to mint. So I go over here. As you remember, we use like the read contract hook. Now I'm going to go to the use scaffold write contract. This docs really makes my life very easier. I can just copy paste. It's pretty simple to understand. And as you can see, like I'll be using this. I need to add some functionality to my button, and I'll directly be getting it from here. So you basically need to add the hook to your application. Let's do it. It's quite similar to the way we added like the read hook. We do need to change the contract details. So instead of like your contract, it'll be NFT, and it's giving us an error because we didn't like import it yet. Okay, so we directly got the right hook. Now we can basically add the functions to like change the state of our smart contract. I might be going a bit fast. I think that's what happens when I talk live. But I will be having Q&A in the end, so hopefully we'll answer questions. And if there are like any questions, feel free to like kind of stop me on the way as well. And okay, so this is called set greeting, which I want to change. I'll be calling this mint. The function is, I think, safe mint, but it'll give us an error if it's not. I think it's underscore safe mint. You can check from your smart contract. Safe mint, and it takes in an address. Okay, so we can pass in our connected wallet address over there. You can see the details of the function here. Value, we'll make it free. And then I'll just pass the connected address here. I think we do this, and then this should work. Oh, do I just do connected address? Okay, cool. So I think we have like a button actually ready to mint. I'll be making this a bit wider because I just like it when it looks a bit wider. And let's see if it actually mints. So how do we understand if it mints? Like let's add like NFTs left here instead of like just the total supply. And to do that, I'm gonna get the token ID as well. So this will be not max supply, but I think token ID, I might be misspelling it. Let's double check. Next token ID. So we'll be, oops, not here, here. This is going to be our token ID. So we get the max supply, but we don't get the token ID. So we don't really know how many NFTs are left. So it doesn't really give us like a good indication. And I kind of want to add that over here. And then let's also add like a token ID. Maybe we can do this here. NFTs left. And then I just do like a minus number. And then I do the token ID. I'm not sure if this is correct, but we'll see. Okay, this is correct. Let's see if it mints, right? Like we added the minting functionality. But if this person mints, the NFTs are decreasing. So I can continuous the mint. And then, you know, this other person with the other colors on the wallet can also mint. Well, this doesn't have any balance, so they won't be able to mint before grabbing funds. But then we can mint, and then this basically kind of allows us to show how many NFTs are left. Okay, this is, we have more time. I feel like we will be finishing before the time finishes as well. But let's make sure I'm not missing anything. I'm just defaulting to the notes which I shared to you guys. So over here, so we basically added like link to our header, we updated our NFT, we updated the front end. We actually didn't do this yet, but we'll do it in just a bit. or sorry, we did. Like, I think I did it before in the previous step. Now, before adding my holdings, I first want to show the gases transactions, or we'll do that in a bit later, because to showcase gases transactions, we need to use base. So I want to kind of finish everything we do on localhost before moving on to like a development and where we deploy the contract to base Sequoia and work with the smart contracts. So for that, I'm going to be, first of all, like just making sure like we can see the NFTs the person has minted on their page as well. And to do that, I'll be going to this NFT app, which is already here. And we're going to be using a component from the Speedrun Ethereum challenge, like the first challenge, where you build an NFT app, and that actually showcases how you can keep track of your NFTs. So we'll be using the component from there directly. And what I want to do is I will get it from here, myholdings.tsx. I'm just going to copy this code. And let's showcase how you can add like a component. I'll be creating a new file here. I'm moving this part a bit fast because it's not the main part of the workshop, but I think it's good to have. And as I said, like whenever you go through the Speedrun Ethereum challenges, you'll see it on the first. Once you get familiar with the challenge over there, you'll see that this component is used, and you can create new components for yourself as well. So I'm creating a new folder, components. And then I'll create like a new file called myholdings.tsx. Okay, I got my the my holdings code over here. Let's showcase how this looks like. I also want to, well, I need to bring that component into here. Let's add it just here. Oh. This doesn't actually take an argument. Let's see what this looks like. Oh, this actually directly connected my smart contract wallet. Okay, so we directly brought in the component. The other one directly connected my smart wallet on Coinbase, so that's why you didn't see it, but I have too many browsers open. But this was the one where we minted the NFTs. So as you can see, like 0, 1, 2, 3, I can mint more, I will see them. Next, we'll also add like a functionality where only one person can mint one NFT, because we don't want like one person to mint all the NFTs. You can, but not in our app's case. But I can continue to mint. This just like shows it nicer. I want to add a header over here to say that these are your NFTs. So this is my I'll copy this. Well, I'll delete the card title, but let's make this. I'm not exactly sure the type we can use, but I'll get it from over here. Like, let's get this page. Let's use H1 actually. Like, this will be better. Let's give some styling to that. I'm going to directly copy from here. I'm just going to add a top margin. Okay, cool. So you can see like your NFTs, you can see like mint more. So this kind of displays over here. This is basically, is kind of almost ready there. We still have a lot of time, but we will be showcasing how you can mint gaslessly, so you don't have to pay gas or have any money. So okay, let's go. I think I'm missing something, but hopefully that will come out once we are working, and if it breaks, we'll go back and see what's breaking. So I have over here the function to mint the NFT, which I directly got, but I want to sponsor the transactions. And for that, I actually went and got my... So let's deploy this app first on Base, Sefolia, and then add the smart wallet piece. Or let's see how... I'm going to add a new button over here. It's going to be quite similar. I'm just going to copy this. I'm going to call this gasless mint. For now, let's remove what it has inside, and then we'll add it separately. Oh, okay, we removed the formatting, which I actually did not want to remove. I'll just remove the functionality, the on-click action. Cool, so this, when we click this, this will be a gasless mint. So then basically what will happen is you can click it and then you won't be having to pay gas, because every time we mint an NFT, as you can see, like our balance decreases, so you need to have like some ETH in your account already to be able to mint the NFT itself. And what I want to do, once again, I remember what I forgot, is basically I want one person to mint one NFT. So then I don't want like a person coming and like minting 20 of the same NFTs, because there can be a lot of like AI agents or something like that. And I'm going to directly go over to the code, which we have over here before. I'm just going to get that part. This will be by the mapping. So what I need to do is I need to add a mapping to keep track of all the addresses I already have. Well, all the addresses who have minted the NFT, and then a Boolean as like true, false, meaning does this person already have an NFT? And I'm going to go back to my smart contract over here. I'll add it here. Already minted. I want the formatting better. So the already minted. And we need to update our safe mint contract to see, like our safe mint function to see if the contract was already minted. And I'll directly get, oh, this already gave it to me. So if already minted is false, it's true, it's already minted. And what we need to do is we actually need to set this. So once this person is minted, I need to add it like true over here. And I think this is good. An important thing to do is like not to add this after the safe mint line, because then like someone can like come in and like they can create a reentrancy attack, and then they can always like mint. So this is important to have it before the function is run. And I think this is okay now. Live workshops are always a bit scary. Cool. Let's redeploy. Every time we change our smart contract, we need to redeploy. Otherwise, it will not be reflected. I'm also redeploying because I want to make sure that only one person can mint the NFT. So then now when we have like a new person, we'll test to see that they can actually only mint one NFT. Okay, so we redeployed the contract. It's a new contract. That's why this person, the pink green person, does not have an NFT at the moment. Let's see if we can mint. Okay, one. Let's see if we can mint again. Okay, already minted. So this person can only mint one NFT. Let's see, just to make sure that I'm not only saying this, but this blue person, let's see if this can mint. So a new person can actually mint, but the same person cannot mint. And instead of already minted, like I want to have like a bit more, please don't Sybil attack me. Okay, so if someone tries to mint twice, they will get that error. I'm just going to get a bit of water. Cool, okay, we're actually going a lot faster than I imagined. It took a lot longer when working on it. So what we can do is, now the important part, probably what everyone is also curious to see, is how we can do the gasless minting part. And basically what happens when you mint, again, just to reiterate, is that you pay for the gas of the transaction, but we want this to be sponsored. So we want to use a paymaster, which will be our application, which will be like, okay, like no need to pay because this app is paying for you. And for that, I am going to follow my steps over here. We built the front end, we updated the NFT contract. Now only one person can mint it one time. There is a max supply, so you cannot pass the max supply of the the count. And then now we need to add like the gases transaction piece. Now for that, we also need to make sure that our app only uses Coinbase Smart Wallet. So we've been using like localhost and the burner wallet thus far, but I don't want that because I want to be showcasing smart wallets and that's functionality. So let's go ahead and update like our WAGMI connector to use the Coinbase Smart Wallet only. And I'm gonna go to do that. I'm gonna copy this code over here. And then by default, even before showing that, I can show you what happens by default. I'll disconnect because I think this is my application. Oops. Oh, I think because it has a burner wallet, it directly connects to my burner wallet. I'd say disconnect, but I can kind of choose the different options. So you can see like there's like all the different options you can choose from, but I only want it so that my app uses Coinbase's Smart Wallet. And for that, I'm going to go somewhere here. I'm not exactly sure, but to my Next.js, to the WAGMI connectors. That is under, not here. The WAGMI connectors. Is it this? No, sorry. I think it's here. Okay, cool. So WAGMI connectors.tsx. And then what we want to do is we only want the Coinbase wallet. As you can see, like it imports all the wallets. We don't want that. And we just want the Coinbase one. So I'm going to delete all of them besides the Coinbase one. And I'll just like basically post what I copied. So the wallets will only be the Coinbase wallet. I delete this. And then the preference is the wallets only. I think this is fine to leave. I don't want to have extra imports, which we're not using. I think we can remove this. So we will no longer have the burner wallets. Because we want to test with the smart wallets, it's going to be a bit like you will actually be testing with the smart wallets, so not as easy. It's still easy, but... Okay, so hopefully this will only be the smart wallets. I actually think we were just discussing this morning. It will show the other options too, but that's on RainbowKit. Okay, we need to connect our wallets. Yeah, so it does show the other wallets, and I'm not exactly sure why, but for now we can continue with the smart wallets. I choose Coinbase. I think I already have a smart wallet set, so I approve this. Perfect. I think I need to change the switch to Foundry. Oh, I'm not sure I can switch to Foundry. But basically, like now I want to make it so that my app is only on base Sefolia, and let's also deploy this smart contract to Sefolia to showcase that. So a few things I need to do here. I've been running Yarn deploy since the beginning of the workshop, and that's only deploying on my local host. So I didn't need to like worry about my account or whatever is going on there. And you can always default to the Scaffold docs to see how like you can get the run deployment scripts as well. I'll just search for deploy. So what you need to do is you need to run yarn generate to create an account for you. I already did that. So what I'll run is yarn account to show the account which I already have. So as you can see, this is the account details. This creates like a .m file which has the details of it. And then you can see like my balance. I actually have quite a bit of balance on different networks. And what I want to do is I want to, did I do it wrong? Oh, yes, I need to update the README file. It's good to have you guys in the front. So I think I used the custom, the default hook. I need to use the custom one, so then it doesn't, I'm not exactly sure where, I think like this. Okay, and the Foundry folder. Okay, so I needed to change my ETH key store to use the custom one, and we did that, so we can run it again. So when I do a Yarn account, it asks for my password. I already said it before. You set it when you run Yarn account the first time, so that's why I'm not setting it again. It's stored with the password, so that makes it easier. But I should have some balance, which will allow us to deploy the smart contract. You can see my account details, base Sefolia. I just am waiting for base Sefolia to appear, and then we'll run the command. Okay, cool. So we have some balance on base Sefolia. I have not deployed my contract yet, so this time we will actually run yarn deploy -- network base Sefolia, and hopefully this will deploy the app if everything goes well. It's pretty fast and cheap to deploy to base Sefolia. Well, base Sefolia is already like cheap, I mean priceless, but I entered my password again. Cool, so our contract is getting deployed. Nice. So one other thing I want to change is my scaffold ETH application is pointing to localhost. I want to make sure that it points to like base Sefolia, because as we were working before, it gets the contract details from the localhost, where the files are generated. But now I wanted to like point to base. And I'll do this by localhost, I think. I'll just check that over here as well. It's in my Next.js app. I think it's in my next config. No. Oh. Not here. I'll just close this Foundry, and then I will So the target networks over here is change.foundry. If you had chosen hard hat, it would have said hard hat. But because we chose Foundry, it says Foundry. And then I'll just delete this, and it automatically gives me like, well, base Sefolia. So this is my scaffold ETH application configuration, which now points to base Sefolia. I'll also lower this because base block times are lower, so 3,000 should be enough. So then our app updates much quicker than waiting for like 30,000 seconds. It can update in 3,000. And everything else should be okay. Nice. Let's see what we have. It didn't change much. We'll create this like a const so that it doesn't show NA afterwards. Like we'll add it as a state to our application. But for now, this should be okay. So I'm going to connect wallets. Okay, it asks me for my Coinbase wallet. Approve. Now my wallet is connecting. I think this is doing like ENS resolution, which maybe need to change, but I actually don't need the address here. I can mint over here, but I'm on the switch to base Sefolia. This person doesn't have any money, so they can't mint. But the good thing will be is we don't have, like, for now, it won't be able to mint because this person doesn't have. Oh, actually, Base does. Base already offers sponsorship, but we're going to do it ourselves. So then you can also see how you can do it in your app. But because like Base already covers the payments, like if it's less than a certain amount, I don't remember what that threshold was. But if it's under a certain amount, Base does cover the network fee. So they already have, like, as you can see, supported by Base. But when we cover it, it'll actually be, say, like supported by Scaffold ETH app. So that's kind of what we want to do. We can say confirm to see like if this actually works. Cool, so this was actually paid by Base. But we want ourselves to pay for it. But this was pretty cool. I actually didn't realize that we could showcase like Base's paymaster as well. but I want to showcase how we can pay, like add it as well. Now I'll directly copy the code, which I have from before. Now, I know I'm going fast a bit, as I mentioned, but all the instructions are available in the README. So you can totally like follow along. I have some extra links over there, so you can kind of check to see where the details are coming from. But this README over here should be like a nice guide for you to like look for if you have any questions about anything we're going on in the workshop. So hopefully that will be like a nice resource. And we might have some quite time for Q&A afterwards too. Okay. I want to make gasless NFTs. I'm basically done with everything I did with my contract side, so we can just close the Foundry folder and let it be. I'm going to go to my app, I'm going to go to my NFT, I'm going to go to my page.tsx, and I'm going to add like a new button here. I'm going to copy the code which I had, and then I will remove this gasless mint. NFTs left, nothing changed here, the mint button, so I added a new button. Now, what we need to do is we need to get our paymaster URL from Coinbase's Coinbase developer portal. I can showcase that. Coinbase CDP. You need to create an account over here, and it gives you like different tools to use. I think I already have an account, so that should be fine. Hopefully this will log me in. But the Coinbase developer portal offers you like different tools, such as like how you can use the on-chain tools, the paymaster, and like the faucet, etc. So I'll be using the paymaster URL, so then I can automatically like cover the cost. They actually also pay for the first, like I think for the $100 or like $500. So that's pretty cool. I go to the paymaster on-chain tools. I go to the configuration tab. It will expose my API key, but I will make it like redeploy it afterwards. So I go over here. I'm on base Sequoia, so I need like a paymaster endpoint to make sure that my costs are covered by Coinbase. Right, async. Did I forget something? So first things I'm going to do is I need to add this as an environmental variable. I can actually add it, like, as you can see, this directly goes from the public paymaster URL. So let's add this over here. We can add it to our .m file. We have, I'm just going to copy this, command copy, .env. I'll create like a, and then I'll go get my API key. So this should be okay. And then we don't need this anymore. Write contract async. So I do need the write contract async, and let's get that from Scaffold ETH. I think we're missing the imports. Oh. Oh, from WAGMI, okay. I remember. So you can go to WAGMI, and I will actually show the documentation as well. So this is under the experimental tab. And I will import. Can I import it from here? And I guess I need to like pull the write contract ASICs from here. I'll delete the notification. Just going to copy from my code as well. I think I'm missing something, but we can quickly cheat from the code I have before. So I basically close the Coinbase developer portal. We don't need that anymore. And then I go over here to my, I'll just go back to GitHub. I think I closed that tab to just make sure that I have the right code over here. I think I'm missing something, but I'm not exactly sure. I'm going to go to my app, to my NFT, to my page.tsx. And then I have the right contract async. Oh, I didn't get my use deployed contract info. Okay, so basically you can use the scaffold hook to get the use like the deployed contract information, which is going to be like your NFT like your contract address and ABI information. And I need to import this. This will give me where to import it from. I think we're good. I don't think there's a mistake, but if so, we'll see. I go over here to my NFT tab. Wrong network. Let's switch to Base. But which wallet is this? Let's just disconnect to make sure we have the right one. I connect my Coinbase wallet. Okay, cool. I need to do like a gaseous mint. Hopefully, this should work. Okay. Okay, cool. So this does work. No need to panic. So as you can see, what we did was we got our paymaster URL from Coinbase's, and you can, I forget which ERC it's defined. It's 5774, I think, but I have the details over here. Devcon 24. Just to make sure that, so 5792, which allows for like batch transactions and gas sponsorship, and then the 7677, which shows it on your user interface when you go to the Coinbase wallet, and it directly says, you know, sponsored by Scaffold or sponsored by Coinbase. So this is pretty cool. Now everyone who has this app can actually use it and mint an NFT. And it is sponsored, when you click mint, it's sponsored by Base, but when you click gaseous mint, it's sponsored by us. That's actually just allow like that it's sponsored by us. And I'll remove the gaseous mint function. Like, let's actually try that it's actually minted. Cool. So we can basically like mint an NFT. We can have it here, and you can do it like when you click mint. It's actually sponsored by Coinbase, which is cool as well. Oh, okay. Maybe they all. Oh, so we got the message because already minted. Please don't Sybil attack me. But another, like if we open like another tab and a new wallet, it should be able to work. So that's when Coinbase is sponsored. Let's delete this mint tab, and then let's make it only our app is sponsored. And then let's actually ship this app to Vercel so that you guys can access it and mint the Buffalo for free. I'm going to delete this. We don't need this anymore. I don't like to have imports that I don't use. I think this is fine. Let's delete this. I think we're good. So just to reiterate, like all the stuff we did was we created a new smart contract, ERC721 smart contract, and then we deployed it to Base. We added like some extra functions. We used the OpenZeppelin wizard to kind of follow along. But as I said, you don't need to like create the index and the people tracking over there. but you can use like the graph or ponder for getting that information off chain as well, like easier without like having your smart contracts there. And then we added like the Coinbase Paymaster URL to sponsor transactions. We had some stressful moments there, but it was solved. So I think this is good. All we need to do is we need to ship our app to Vercel, so then I can give the link to access. But this is basically completed so far. And to do that, we actually have just one simple command, yarn Vercel YOLO. I think this is fine. I already have my Vercel account linked, but if you don't, I think it actually asks for you to like link your Vercel account first. I'm gonna do no, and I want like a new project. Let's call this Buffalo, or let's call this like Speed Run Ethereum NFT. Yes. I want the default settings. Now, one thing is I do actually need to add my Paymaster URL to my Vercel account, so we will do that in just a bit. But besides that, it's pretty okay. I can actually follow this link. I'm going to go to my Brave browser. Where's my Brave? I'm going to go to my project. I think on my... So this is building. This takes a while. Well, not a while, but like a few minutes. And I need to add my .env file details over here, somewhere here. Okay, somewhere here, sorry, environmental variables, blah, blah, blah. And we add them here. So it's actually pretty cool. You can just copy paste from our code. Let's go. Let's go, let's copy this. We can directly add this. We can directly add this here. This will save. Okay, nice. So this should be added. We do need to redeploy your application. I think I can go over here and like redeploy. Oops, speed on Ethereum. I'm redeploying because I added like a new environmental variable, so it kind of takes that in. Otherwise, it wasn't going to use my, because it doesn't push the .env file, it won't like know which process variable to look at. And this takes like just a few minutes, and then afterwards, hopefully you guys will all have access to the link, and you can try it out. Any questions? Like maybe we can like answer. Oh, the deployment is successful, or? Yeah, if anyone has any questions, like happy to answer any questions you guys might have while this is deploying for a moment. Hopefully it will deploy fast. I feel like pauses are awkward. And just to mention once more time, when you go to the Scaffold docs, all this information is available over there, like how you can do like a Vercel YOLO, a Vercel deploy, or you know anything. All the things we went through are actually available here. We added our own smart contract, but you can also like interact with already existing smart contracts and find the details here. It's quite easy to pull it in your app. I guess the biggest feature is that you can kind of iterate quite fast. You can like post smart contracts, make changes to your app. Like we built like a whole gases NFT minting application in like an hour or so. And we deploy the contracts. We even like have a live URL in just a moment. Once this is built. And what else? Am I forgetting something? I think we did talk about a lot of the things. I can show speedrun Ethereum one more time. So to get the components which shows like who has the NFTs already, we basically use the simple NFT example component there. So I know I went through that really fast and I just copy pasted it, but when you go to the simple NFT example, it will show you the details of that component. So you can kind of understand how to build your own components, such as the small card which shows like the NFT. And then you can basically follow through. You can create like a decentralized staking app, a token vendor, dice game, join the Build Guild, and other challenges as well. And then to follow more about what's up in Build Guild, you can also go to buildguild.com to kind of see the stuff we work on. And you'll have over here Scaffold ETH. You can start using, start building. This kind of gives you all the information you need. We have an extensions feature as well, and Hunter, the creator of the video, is also here. So basically, extensions allow you to add new features without modifying the existing code. It's funny to see, yes, your face here as well. But basically, you can kind of follow along to see how to create extensions. And what I mean by extensions is, let's say you want to extend your Scaffold ETH app, like add a new smart contract, right? Like we added like the ERC 721 contract, and then you can kind of be like, I want to make it easy for anyone to create like a Scaffold ETH app with the ERC 721 contract. So that's kind of what the extensions allow. And this video teaches you how to do that very simply, so highly recommended. And you can learn more about extensions. You can create available extensions. So there are like some which are available out of the box, such as like the subgraph, the on-chain kit one, ERC 712 is also available here. But 721 is not, so maybe we can create an extension afterwards. Not live, that would be a bit too stressful. But I hope Vercel has deployed. Oops, Vercel has not deployed. But, I have like a something error on my page with extra quotes, but I'm not sure where I have that error. Yes, because YOLO shouldn't scream for the linting errors, right? Oh, okay, so I got it. These are like warnings which I should do it again, which will redeploy because YOLO is like not checking for like linting errors. But now this means we have like an extra minute. So, but yeah, the reason was I think I have like some wrong quotes or something which was creating like a linting error, which blocked me from like deploying to Vercel. And yes, I think it's okay to have it for now. That's something you can fix afterwards. I would have known the error. True. In case it didn't go through to like the video, but that's a good point. Like you can do like a yarn Vercel build, or is it yarn next build? Yeah, let's look at that. Since we have a few more moments, we can do that. But that's a good point. Thanks for mentioning that. I think it's okay. I'll just go to my. So you can run like a build command directly to make sure that it doesn't have any errors. And then this will directly give you the errors. So before you push them, you can fix them. And it tells you all the scripts, like when we run like yarn start, etc. This is kind of the commands that I run. But I didn't do that, so I didn't realize I had an error before. But that's like a good feature to, well, best practice to do before. But now this is actually deploying to a new link, right? Like did this create like a new application? Let's see, inspect, not that one. So I might need to actually add our paymaster URL, or is this creating the same one? Okay, I think this worked, but we didn't add the. Let's see. We'll see and try. If it, I think it created like a new app, so we should add like the paymaster URL here as well. Oh, it directly created the same one. Okay, so it directly used our environmental variables already available in that case. Oops, not here. Let's just follow the. Or I want to use this link actually. This is better. I'm going to connect our Coinbase wallets. We're going to do gas assessment. Going to work? So not going to work. Makes expensive. Okay, as you can see, sponsored by Scaffold ETH. Let's mint unknown NFT. You probably don't want to mint unknown stuff. Okay, nice. So all of you guys can actually go to the URL here, and I think I have like a better share, right? If I... The what? The project? I'm not sure where. I think the URL is. But where does it show that one? The settings. Okay. So I go to the NFT tab. So everyone can actually go to this domain and like mint an NFT. It's speedrun Ethereum line dash or line nft.vercel.app/nft. We should have actually removed like the homepage and the debug contracts before we did the deployments, but we did do Vercel YOLO, so we didn't really check those stuff. So yeah, like this is kind of the gist of the workshop. Happy to answer any questions you have. Before doing the Vercel deployment, it is very important to run like a yarn build, I think. So then you can check the errors before you deploy. But our error was like a small like linting error, so it didn't really matter. Like it was a warning. Yeah, this is happy to answer any questions anyone has. But we're 25 minutes early. I think it's okay to be early. And you can send questions through here, I think, right? That's the thing.
Hey, can you go through the My Holdings component? How do you fetch the NFTs for each user?
Yes. Can we connect again? So what I did there is, that's a good point, because I moved through it really fast. But we have over here the app components, My Holdings. So this uses like the enumerable, right? Like when we were deploying the contract, we also make sure that we can have like tracking the IDs of who was the account that was minted it. We have like a mapping over here on our NFT smart contract, and I can show that as well. But we made it enumerable, and then we have like a mapping to kind of keep, well, the mapping is actually not how we track it, but that's kind of the functions we get out of the box to allow it.
Okay.
Does that make sense?
Yeah, just wondering if we had like, let's say 10,000 NFTs or 100,000 NFTs, would you have to go through all of them checking which one is the owner? There, the for loop.
So yes, right? Like that would create. So that's why you probably want to use like Ponder or like the graph or something like that. This was an easy way to do it at the workshop. You probably don't want to have those smart contracts. It's just extra workload for your smart contracts. But it does make it easier for like smaller projects or like for workshops. But yeah, you probably want to use like Ponder or GraphQL.
Okay, thank you.
Actually, there's an extensions for both of them. So you can directly use the extensions to create like your app out of the box with those features. So we mentioned about the extensions and how you can use them. So the available extensions are like you both have the subgraph extension. So then that way like it just indexes this. So with subgraph it uses like on-chain indexing. With Ponder like it's off-chain, which kind of makes it really faster. So you can kind of do that. Okay, cool. Well, if you have any questions, we're here. And thank you to everyone at Build Guild, especially Shiv, for like helping out super much with the application. I'm more representing us both here. So yeah, if you have any questions about Scaffold ETH, about Build Guild, happy to answer. We do have like most of the developers here, so I hope that they can provide any other like ultra deep dive technical questions. But yeah, I guess this is kind of the end of if there are no more questions, like we are done.